Hi, I thought as we'd had one on the Borden barometer, it seemed fitting to have one on the Vidi barometer, which is the type you normally find. What I should have mentioned on the last talk I gave was the column of mercury held up by air pressure up to 30 inches. The space at the top was known as a Torricellian vacuum. And it was also noted in times past that when this type of barometer was moved from one place to another, it was noted, and the gentleman's name has actually slipped me, but it was in France, that the movement of the mercury in the tube caused light or an electrical discharge to be seen in the tube, and this was probably the first time that a fluorescent lamps, or the principle behind it, was noted. So it's interesting to just mention that point. This goes back a long time. Obviously the whole phenomena wasn't really taken seriously, but it was probably due to the mercury vapour in the vacuum and the movement of the whole barometer being taken out, because people used to do that in the old days. They were so conscious about the actual weather. Anyhow, getting back to the movement on this one, this is actually one of the better movements. You've still got your rain change fair, made by the German firm of Scholz, and it's a very well made barometer. You can see all the actual levers. Now the vacuum chamber is that white metal corrugated piece, the circular piece right down the bottom there. You see the corrugations. That is a vacuum chamber. It is held open or apart, stretched apart, by the silver spring that you can see on the top there. That is a spring. That tends to keep it open. So although there's a vacuum in there, if you can imagine that as a concertina tin box, if you like, being pulled apart, so it's being held under tension of that spring and being pulled apart. At the same time, attached to the let me find it, I'm going to try and get it exactly right, because yeah, it's fixed. The variations set up by the changing air pressure acts upon this tin can, for a case of better words, and it alters it, and it acts against the spring. Now attached to the spring you've got another lever. In this case it's got two, it's like a yoke, and that lever in fact moves minutely. You couldn't see it move, it's very minute. And by looking what happens at the bottom, I'll try and, I've got high intensity light but I can't always, I'm trying to get it in as best as I can. It's connected to a set of levers. I'm sorry, I can't seem to get it any better, but take my word for it, it's connected to a set of levers which increase the travel, and the lever has this centre spigot sticking up, and if you look very carefully you will see a chain. It's a fusee chain. It's a fusee, which is like a chain you'd find on a motorbike or a bike. It's a chain with like links, and that goes up to the centre spindle where the pointer is, and is wrapped around a little pulley. It's very, very small, wrapped around the pulley. So as the variations take place, the pointer is pulled round in either direction. As the pressure goes up, it goes in a clockwise direction, and the other direction if the air pressure gets less. Now the spring, the whole pointer is kept in place by a hairspring, which you can just see there. I'm sorry about that, you just see a hairspring. There's the hairspring. I've got to get in such a, there we are, there's the hairspring. You can see the fusee chain, and there's the hairspring, and that movement acts against the hairspring, so it's always there without flopping all over the place. So that's more or less the principles of the aneroid barometer. To adjust it, now if you lived on the top of the mountain, obviously the pressure would be different as if you lived at sea level. So there will always be, we turn it round to the back, an adjusting screw, and that little screw under the open part is for adjusting, and all it does, it moves the connection to that heavy spring with respect to the vacuum chamber. You can see the fine adjustment there, and that is how you would adjust it. Anyhow, we've seen the two types, the Vidi, which is this one, and the Borden, which uses the curved tube. Anyhow, once again, I hope I haven't bored you, and any questions please ask. Thanks for looking, please subscribe, and thank you again.